Hello, my name is Justin Barksdale. I'm a technical marketing engineer in the Office of the CTO in the Cloud and Compute Business Unit here at Cisco. So today I'm going to talk about cloud innovations that we've made in Intersight over the last few months. So I want to level set really what is Intersight. Intersight is our cloud operations platform. So it's a series of services that are put together in order to support both on-premises as well as public cloud infrastructure. It also provides the ability to level set the application experience regardless of where that application lives. So services such as Intersight Infrastructure Services provide us the ability to provision UCS and other types of infrastructure. Intersight Workload Optimizer provides us the ability to level set or normalize the application experience across both public and private cloud instances. And Intersight Services for Terraform provides us the ability to give our customers a cloud-like experience, so the same infrastructure as code experiences they've come to know and love in public cloud for on-premises infrastructure. Now today I'm going to talk to you about three additional services: Intersight Cloud Orchestrator, Intersight Workload Engine, and then Service Mesh Manager, which is really an extension or add-on on top of Intersight Kubernetes services. So Intersight Workload Engine. Really, the challenge that we've seen inside of customers is that they have a lot of different types of configurations, a lot of different types of infrastructure. And managing that infrastructure for the application, which is what we're really talking about, has become more and more challenging. So whether it's compute, network, storage, sprawl, different types of firmware, different versions of code, all of these things have to be lifecycle managed and have to be secured when there are new patches come out and things of that nature. You add on the operating system that lives on, say, a bare metal instance, and now I have to lifecycle manage that as well. Layer on a hypervisor, other additional networking and storage and compute services, and then another operating system, and I have teams of people that are there to manage and lifecycle and secure these different components. Think about it whenever we start getting into cloud native, though. Now we have container runtimes we have to worry about that are loaded on our bare metal servers, maybe. Or we have just container runtimes on top of virtual machines and then containers on top of that we have to secure. So the sprawl really becomes a problem for our customers. And this is really what we intended IWE, Intersight Workload Engine, and IKS to solve. Initially focused on cloud native applications. So this platform is managed from Intersight. It provides the security services, management services, operation services for all of the underlying infrastructure, whether that's storage, compute, network, everything end to end, the operating systems themselves, the container runtimes, etc., for our cloud native applications. In our initial deployment, which is going to be in the next month or two, we'll have it supporting just cloud native apps. So think of things running on Kubernetes. This is going to eventually evolve into supporting traditional applications, whether those applications are bare metal or they're just traditional virtual machines. We're looking to support the entire stack, be able to provide our customers with an operations platform that manages end-to-end their infrastructure, regardless of what type of application is deployed on it. So if I dive into kind of where IWE fits into the ecosystem, we've talked in the past about server management. We've talked about how Intersight manages firmware and BIOS policies, etc. This has pretty much been the de facto standard for the last decade or so. We layer on IWE, which is really built on IWE OS, as Cisco, and then clustering and hypervisor components are part of that. Additionally, we have services like Intersight Virtualization Services, which handle the day-to-day operations of, say, virtual machines, spinning up, spinning down, scaling, destroying, VM migration, etc., on top of the IWE platform. And then IKS, layered on top, gives us those Kubernetes services that have been out in the field for quite some time. Now, initially, our goal, as I said, is to target applications in containers on top of virtual machines. So this will be the first iteration of what IWE offers. We'll follow that very shortly with applications and containers on top of bare metal servers. There's a lot of use cases around being able to support, say, high performance networking that need to have no hypervisor overhead, as an example, or AI ML workloads that don't want to take those CPU hits with a hypervisor, giving direct access to maybe GPUs as part of this bare metal service. And then in the end, we'll support applications just running on VMs. So just traditional virtual machines running on top of IWE. I'm going to pause and just see if there's any questions.
I have a question.
Yes.
You said you want to be able to support bare metal servers. So Which flavors of servers? Will it only be Cisco, or will it be which kind of servers will you support?
So the intent is to support, generic. I will say that, obviously the initial phase will be just focused on Cisco servers, UCS. But with Intersight and the platform, the ability to support third-party servers is certainly capable. It's just a matter of us going through the testing process.
Thank you.
Would that include some of the server management functions like the firmware and BIOS stuff? Because I think that would probably be quite different on different models of servers.
It would. I think in ideally, yes. Obviously, Intersight's built on Redfish, and as long as the providers are using Redfish, that's capable. Again, I think it'd go back to like testing and saying, well, this is what we qualify, et cetera. But initially, it will just focus on UCS.
I just want to repeat the same questions, but in the Kubernetes space. Instead of talking about in the virtual hypervisors or bare metal in terms of Kubernetes, are we just talking about open source Kubernetes, or what flavors of Kubernetes allows this?
So it is open source. We're just using upstream Kubernetes. And in the next couple of slides, I'll actually dive into the architecture of maybe a little bit deeper, peel back the covers of what IWE is really built up. But it is, at the end of the day, upstream Kubernetes.
Thank you.
Okay. All right. So what is it made of? Well, IWE is made up of a couple of things. One, we have a secure Linux distribution that runs on top of bare metal server. On top of that, we're deploying our IWE services, and these are services that Cisco intellectual property that do things like the device connector to talk to Intersight, lifecycle management, API services, etc. We also have traditional Kubernetes services, and Nathan, to your comment, this is really the services that are just upstream Kubernetes. So when we peel back a little bit further and look at the overall view of the cluster, we have these IWE services, but now we have multiple nodes that are running just Kubernetes services. Now there's 3 masters, so those 3 masters running etcd and some other master services like API interface, things like that. But as well as we have the worker nodes that are running, just kubelets so that workloads can be put on. So this is really the makeup and foundation of what IWE is built off of. But keep in mind, this is all on bare metal. So we are deploying this. We're provisioning out the Linux distribution, provisioning out the IWE services and the other components, putting it on top of the bare metal bits. Again, we talked about this UCS at first, potentially third party later on. And this is all managed via Intersight. So from a customer's perspective, I'm simply saying I need an IWE cluster. I have X number of nodes and I want to deploy that to it. I click a button, and that's simplistic, right? But I click a button, fill out some forms, some IP information, etc. And then I get my IWE cluster. But from a management perspective, it's all from Intersight. They do not interact with the local Kubernetes services that are on these machines. This is all abstracted from them via Intersight, okay? And I'll tell you why in just a moment. So when we drill into how we provide virtual services, now again, Intersight's managing these, but we're creating virtual machines basically as CRDs inside of our Kubernetes cluster that's IWE on premises. And so now Intersight's doing that provisioning. That's where IVS, the Intersight Virtualization Service, comes into play. It gives us the ability to create virtual machines, but under the covers, we're really just managing them just like any other Kubernetes object as a CRD. Now, say a customer wants to have the ability, and this is phase 1, right? Where I want to deploy my application on virtual machines on top of IWE. That's really where, okay, now I'm taking Intersight, I've deployed IWE, I clicked that button and got my cluster. And now I say, I need Kubernetes services. I build out tenant clusters on top of that. Customers do have access to these, right? They have access to go through the underlying, to the tenant clusters to deploy their applications or whatever it is that they need to do. In the phase 1, this is what this will look like. All right, I'll pause there just to see if there's any additional questions.
Yeah, I've got a couple. Just from the previous 2 slides, I just want to make sure it's clear what you're trying to communicate here. Are we creating a cluster that creates additional clusters within virtual machines, or is this a different type of way of running different Kubernetes CRDs or custom resource definitions within IWE?
So I think what I heard you ask is really how are we deploying the clusters? What is the makeup of the 2 different types of clusters? Is that pretty accurate? So IWE is an instantiation of a cluster of compute resources that happen to serve up things as Kubernetes CRDs. In itself, again, the abstraction layer is to make the complexity away from the customer. So really what they're just seeing is a block of resources. then they can consume those resources how they want to. So let's say they want to consume them with, again, virtual machines, IKS running on top of it. That's the first phase. Phase 2 is to say, I want to add bare metal containers onto there. Now I have an IWE cluster, but I'm not actually interacting with that directly. I'm interacting through Intersight. Does that answer your question?
Yeah, so we're going to go back and forth just to make sure that we're communicating here.
Sure.
But what I'm hearing is that you have the option to run bare metal pods on top of IWE, but you also have the ability to, through custom resource definitions or CRDs, to substantiate like virtual machines, or even, and this is where I'm kind of curious, are we able to substantiate internal clusters within that bare metal interface? Something
Yes.
like what Cluster API does.
Correct. So I think that's the 3 phases. So phase 1 is the latter part, what you just described, which is I instantiate IKS clusters, so Intersight Kubernetes clusters on top of IWE via virtual machines. That's phase 1. Phase 2 is to support Kubernetes pods on top of bare metal servers. So just part of an extension of IWE, so it has access to the storage and things like that, but I'm just running it bare metal. And then phase 3 is just VMs as CRDs. But again, the CRD bits, and that is all hidden from the customer, right? We're doing it from Intersight virtualization services. Now, you could do it via API, you could do it via SDK, or however else you want to do it in Intersight. But the challenging parts of understanding how Kubernetes works with CRDs, et cetera, is really not visible to the customer.
So for this slide, because I don't know all the Cisco products and names, so I'm getting super lost as you're trying to
Sure.
explain it. And I understand the 3 parts, but I don't understand what the different products do. So for this slide, for instance, that you have pulled up, where is Intersight? And I'm not even really sure what Intersight does. I'm really sorry, but like, where does it fit in this whole thing?
So if you look at this slide, this is the makeup of the on-premises components inside of your environment. So your servers, which are the IWE nodes, right? They have compute, memory, storage. You have a layer of, in this case, we're showing a Kubernetes layer, an IWE cluster makes up all of this. And then Intersight's managing it. So all of these bits talk out to Intersight, and Intersight is a cloud management platform, which is what we leverage to, if you're familiar with Cisco UCS as an example, this is the evolution of UCS to be able to manage infrastructure regardless of location, on premises or in public cloud, in the same manner, and providing it via SaaS service today.
So does Insight have some secret sauce that end users aren't able to access that actually does that provisioning, or is all of that super transparent? Or because you keep saying like this is coming from Insight, so is that pretty transparent how it's coming? Once you have that set up, then you have everything provisioning, and then you break it down into the actual 3 steps for this instance for what we're trying to create.
Correct. So from a customer's perspective, it's I want resources. How many do you need? Oh, I have 5 servers. Okay, I'll build this on the 5 servers. The things that happen in the back end, while Intersight does show like step by step in the logs what's happening, it's really not accessible outside of that. Does that make sense?
It does. So however it actually gets executed is dependent on how Intersight is going to execute that automation. Right. Okay.
Correct.
Okay.
Yep.
And Justin, you told us that Intersight works both on premises and in the cloud, so I can have the same identical model on any cloud, in a major cloud at least. Now, so instead of having a physical node, I can have a VM in the cloud provided by AWS, GCP, or Azure.
In the very phase 1, no. But yes, that is the target, to have IWE services as like spin up EC2 instances and deploy IWE on top of it or whatever. Yes, that is an accurate statement.
Okay. Do you have a timing for this target?
I do not. I don't have time. I mean, I don't have timing for that.
So at the moment, this is an on-premises thing.
Yes, it will be on premises. Intersight being cloud managed and supports multiple clouds, but this particular service will be on premises initially. Yes.
Okay, good.
Okay. Awesome. All right. So the next component that we're going to talk about is Service Mesh Manager. And in order to kind of level set here, I want to give you an idea of what the application is that we're looking at and what are the challenges that we're solving with this. So I have an application that actually exists in two different environments. This application is microservice, so it's broken up. I've got a some front end services that live in EKS in an Amazon environment, and I have some back end services that live on IKS, so Intersight Kubernetes services on premises in a data center somewhere. So if you think about how monolithic applications are built, they don't really have this challenge. It's one binary that's basically running out there, and the services talk internally and everything's happy and great. But when you start breaking those out and you start having to say, like, there are latency dependencies or there are dependencies on communication between these services to make the application experience really good, then it becomes challenging on how you get visibility. You certainly could deploy everything in one environment and get some type of visibility, but since most of this is done via like a command line or some type of infrastructure as code element, that visibility really doesn't exist. Couple that whenever you start separating these things, saying, hey, I have a cluster in the cloud, like a public cloud like Amazon or Google or whatever, and I have another cluster on premises, because that's typically the architecture that we're seeing. A lot of customers are putting their scalable front-end bits inside of a public cloud, but their databases, mainframes, things like that, they're not leaving anytime soon. So how do I get visibility across this when different services are talking? And that's really the challenge that Service Mesh Manager is bringing to the table. Now, again, this is an add-on or an extension into IKS. So today, available with IKS, and I'm going to show you a demonstration of this right now. So this is a live demo. This is Service Mesh Manager dashboard. Quickly in the dashboard, you can see that I get a really quick view of what my workload health is, my service health, and I have some SLO or NSLO established in here that I'll talk about in a little bit about what an SLO is. But basically, I can see the health of how that's looking. And one of the nice views within here is I get really instantaneous view of the overall health of my application living across two different clusters. Again, one in Amazon and one in on IKS. I also can get a topology view of this by just going through the topology and seeing how are things really communicating. Now, this is all context aware, so I'm just going to resize this a little bit to give the view better. But I get the view of how things are communicating. As I said, I have a load generator that's talking to a front-end web server, and that web server is making some API calls to back-end services, checkout services, cart services. This is like a retail application. Now, this is all available to be able to say, I want to look back in a timeline. Maybe I want to look back and say, well, there were some problems back in this particular area. We see some orange that looks like I could have had some service interruption. What was really going on? What did the architecture look like? And you can see how it kind of changes. Now, we had a power outage yesterday in our lab, which is a result of why this is the way it is. But ultimately, these are services that weren't able to communicate and were slowly coming back up. But it just gives you the ability to say what was happening here. And I can actually go back and say, click on one of these and look at, all right, what was the health of this? Well, this shows very unhealthy. We can see some latency issues. I can drill down and say, let's look at the health a little bit closer and look at the latency and see this is the problem. I can also see that it was the source was having issues with latency, which is what generated this particular kind of alert or this particular view showing an unhealthy pod in this environment. All right, any questions about that portion?
Yeah, I have a quick one.
Okay.
Just how are you able to view these metrics? Is this an opinionated deployment when you build the actual clusters, or is this an additional add-on that has to be deployed on top of it?
It is an add-on that you would deploy on top of. So Service Mesh Manager is an Istio. It's leveraging Istio and Envoy to get the metrics back. We have some other components like Prometheus and et cetera, providing the logging monitoring. But then we wrap it up in a pretty GUI for you. But it is an add-on or extension to IKS. So you would say, I want this cluster to participate in the mesh. Now, it's important that I'm showing it across two different clusters, but it could very well be just a single cluster with a lot of services, right? It doesn't have to be multiple.
Okay, so this is part of the service mesh, right? This is not something
Correct.
that you get out of the IKS. Okay, so gotcha.
Thank you. Well, it's an add-on to IKS, yes, but it is a service mesh manager. So basically, deploying service mesh or extending service mesh across multiple clusters, whether it's IKS or not. And in this case, I have IKS and EKS.
Thank you.
Okay. All right, cool. All right, so I'm going to go back to the live view and just kind of drill through this a little bit more. If I go into my workloads, I can see again a list of the workloads that I have. Talked about this. I showed it on the architecture slide, but the workloads that are there are really just the pods that are running. What's the state of them? Again, I can click on my timeline and go back and forth and see how they are performing. I also have the same capabilities inside of services, but what's interesting in services is now I can start getting into this SLO conversation, so service level objectives that maybe I'm trying to meet to match the SLAs that the business has set forth. So I've already set one here on this ad service, and you can see that I am drastically out of compliance. But what I have is really this service level objective, and essentially it's just measuring the success rate of gRPC requests from this application or this component. And really I've set it to say over a 14-day window, I want it to be 99.9% success. Now, again, we had some outages and we had some challenges. So you can see I burned through everything really quick. I'm really over budget, and my actual compliance is 93.58. But this just gives me the ability as an application architect or an SRE to provide these SLOs out of the box very quickly. I can also provide alerts off of this. So if I have some type of ticketing system, I could create an alert, a policy around alerting, and say, I want to create a ticket, or I want to send it to a web page and open up additional resources or whatever to alert on this particular SLO. I can create customized SLOs. So if I go one level up and just look here, creating a new SLO, I have to attach the service level indicator, which is really what I'm measuring. And out of the box, we have some generic HTTP ones. But if I had more custom based on the application, I could create my own and add those in here as well. So giving the ability to have SLOs inside of the environment, again, measuring how those services are communicating together, which is something that becomes really challenging whenever you are spanning across multiple clusters. All right, and then I get a view of my gateways. So in this particular instance, I have 3 Istio gateways. Well, 2 of them are mesh expansion gateways and 1 ingress. If I go back to my drawing, this is really how the communication flows. So I have my application in the cloud, application on-prem. Each of those has a mesh expansion gateway, and that's how they're communicating. And then I have an ingress gateway, which is how applications or people or anything else gets into the mesh. And I'm just going to drill into that very quickly and show you I get metrics about it. So what are the requests? What's going on? Let's say I wanted to create a new gateway. Oops, I didn't want to do that. Let's say I wanted to create a new route. So I have these routes that are here, directing traffic where I want them to go. I have the ability to, add them very quickly from here. Again, this is API driven, so you could do it via APIs, but a lot of customers are looking for that visualization, and this is one of those ways we're giving it back, just adding routes very quickly. All right. Lastly, we have traffic taps. So maybe I have a workload that we're seeing some bad performance or some challenges with. I have the ability to go in here and say I want to tap the traffic. And once the streaming service starts, I'm starting to see those gRPC or any of those HTTP requests coming in, and I can say, you know what? Here's one with an error code of 302. Maybe I need to investigate that a little bit more about why it is. So I get information about the headers, the response, etc. But I can see this really quickly. Likewise, I can filter these. So I've got a lot of requests as I'm streaming. I've got a lot of things going on. Maybe the method I want is get, and the status code is 302. So anyways, I can filter this out by get request and add the response code of whatever I want it to be, just to give me the ability to filter. So giving the streaming service, taking a look at what are the actual requests that are happening, and what is the information back, helping troubleshoot those network connectivity issues that might be a challenge. All right. Lastly, I'll just talk about the mesh itself. So we do get metrics on how the mesh is performing, what resources are being consumed, where we are with any errors, just how the overall mesh itself is performing, which is really a kind of a nice visualization for customers to be able to see. So last but not least is Intersight Cloud Orchestrator, so ICO. And ICO has been an evolution over time of really a couple of different products and solutions that we've kind of merged into being Intersight Assist Cloud Orchestration platform. ICO is continuing to evolve, so we're adding features all the time. And I'm going to walk through really the challenges that we're solving with ICO overall. So what we've seen in customers is you a lot of times see this. I have network or administrators that have an infrastructure folder that has like version 1, version 2, final version, absolutely final version of my infrastructure definition. And that's not even the right folder. There's another folder that says InfraDocs version 2. And so they really don't have the actual definitive blueprint of what their infrastructure should look like. You couple that with things like multiple consoles, email chains, email distribution lists, monitoring tools, and then the ubiquitous Excel spreadsheet that holds all the IP addresses for everything going on. You end up with several challenges within customers. And a couple of them are, again, multiple endpoints and infrastructure. You need to check the infrastructure. Well, I have Excel spreadsheets that define what my IP addresses and VLANs have been used. I still don't really necessarily trust it 100%. I need to go and grab that information from somewhere else and make sure that verify with the infrastructure. Likewise, you get inconsistency because of different documents. Sometimes credentials get stored locally on an administrator's machine because that's the administrator that installed the infrastructure, and I need access to it. I don't have access to that. And all of this leads to really slow and error-prone services. So fundamentally, why do developers love public cloud? Because it's fast. I can click a button and get infrastructure. That's the experience we're trying to bring to the table with Intersight, being able to click a button and get infrastructure. And one of the ways we do that is with Intersight Cloud Orchestrator. So Intersight Cloud Orchestrator out of the box has a series of just workflows that we built, and we're constantly building more and more. Now, these workflows will really help with fundamental IT tasks like creating host groups, creating new storage, things like that. There's obviously the ability to create custom tasks. So now if some of these workflows don't have what I need, maybe I need to add a custom task that is an HTTP request as an example, and make an API call to something that's not built within Intersight or some third party that we don't necessarily have direct integration with. I can build custom tasks. And it's all built in this nice, simple drag and drop low code environment. So my network team, my infrastructure admins, my operators don't necessarily have to know the ins and outs on how to make the infrastructure API calls. They just know what they want to do, really get an outcome. So I'm going to drive through a demo of this. I have in my Intersight environment here, I also have a virtual VMware environment that we're going to orchestrate. And on top of that, I have an ACI environment that I'll just log back into real quick. So my Intersight environment, I see very quickly in the dashboard, Gina, I think you were asking, this is Intersight as a whole. This is the cloud operations platform, giving you visibility into how your infrastructure is performing, how your applications are performing, and being able to manage those. I'm going to go through down into the orchestration tab just to kind of show you what we have inside of Intersight Cloud Orchestrator. So I have a series, again, out-of-the-box workflows that are built. Things like, a new storage virtual machine, a new virtual machine, those IVS services that we talked about a little bit during the IWE conversation. This is where I can go and instantiate like a new workflow to deploy that. I also have a series of out-of-the-box tasks. So tasks that that we've deemed are necessary for those workflows. So if you think in the constructs, a workflow consists of tasks stitched together. That's how that works. So I've got a lot of out-of-the-box tasks. I can create custom tasks, whatever I need to do there. What I'm going to do here is go back to my workflows, and I've set up just some labels to quickly filter the workflows that I have for today. And so I'm going to click on my Tech Field Day tab, and I can add tabs for whatever. But I have one that says Create ACI Infrastructure. Now, again, this brings you to the Workflow Designer, where I have a series of tasks that are here that are doing varying things. They're creating a new tenant in ACI, bridge domains, ACI constructs that are needed to build networking. My customer example is really around, I need to have new infrastructure to provision my new application that's going to be on VMware. So in this case, I'm provisioning new networking. I'm also provisioning the port groups inside of vCenter so that the virtual machines can be added to them. Now, if I look at this a little bit closer, the workflow consists of workflow inputs. These are the things that I'm going to ask the user when they click execute. And I'll show you these in a moment when I execute this task. These map to task inputs. Remember, a workflow map is made up of tasks. So these map to task inputs. And so the example I'll use is like the VLAN, for example, is mapped to the VLAN ID for my port group. Okay, just this quickly gives me a visualization of what's here. Now, if I had output requirements, I can map those to outputs and ultimately give those to workflow outputs. I don't have any of those in this particular instance, but I could. I can also look at this from a code view. So more advanced users that maybe are very familiar with what's going on can manipulate the code directly in future releases. I could also take this and say import and export code more quickly to bring this to new environments, to new, however I want to distribute that. So giving you a code view of this environment. Remember, we're trying to be low code, but I am giving you the view from a more expert standpoint of the code. So I'm going to pause there and see if there's any questions about Intersight Cloud Orchestrator at the moment.
So this looks kind of like JSON. Can you also do this with YAML?
So there is work being done. This is JSON. There's work being done around being able to import YAML definitions for varying components. We do have integration like with Terraform as an example for HCL, but the YAML bits, there is work being done, yes.
Okay. Can you use this with custom code if I wanted to run like a Python script or something within this?
So right now, the task that we have is an HTTP executor. There is also roadmapped very shortly to have a Python, PowerShell. You can kind of run the gamut there of what are popular, but executors that run those SSH that run those specific tasks as a component. So basically, to your point, Nathan, you would create a new task, an executor for SSH or Python or PowerShell, drop your code in there, and that would be my task to do whatever it was doing. And that is being worked on and scoped as we speak.
Awesome. Thank you.
Okay, cool.
So if you can build, if you can build your own, if you can build your own things, is there any restrictions to, building your own
task?
Yeah, tasks for say an HP or a Dell server, something like that.
At the end of the day, right now we support HTTP executors, so you could, if they have an API, we can make an API call and do it. I think the only restriction might be around how they authenticate. If they require, like for example, two-factor or things like that, that might not be in the HTTP executor, but just generic authentication is available, and we can use tokens and cookies and stuff too.
And there's so much, there's so many different elements to all of the different tasks, right? So how often are these things updated, and how is that communicated? Especially if you're, it seems like you're trying to market it towards people who don't code and really don't really have an infrastructure background. So how often is this updated, or is it just clearly marked that you have all the different versions? And if it's easy to code, do you have to be responsible to know which version you need, or like how does that all work together?
So we do have versioning built in. When you clone or create a new workflow, you can create version 2 or however you want to do that. There's also work being done to integrate with Git. So Nathan, this might go back to your components where we have like integration with Git to be able to do version control there. That's something that we're definitely working on too. But right now, just versioning through the GUI or through the API is the way that we would do it.
Okay, thanks.
Sure. So I have this task here, and I'm going to just quickly execute. But one of the things I want to talk about is this is running in an environment. So I have Intersight Cloud, which is talking to what we call Intersight Assist, which is an appliance, a virtual appliance that lives on premises. And it's actually doing the execution. So I have infrastructure. I showed you VMware and ACI that live on premises. I want to execute something against them. It's the Intersight Assist appliance that's doing that. Intersight is telling it to do it. So that the purpose behind me calling this out is that I don't want you don't have to open up firewall rules to let Intersight talk directly to your infrastructure. We're doing this through the Intersight Assist appliance. So I'm going to run this really quick. I do have to get my password, which I think I saved in my clipboard, but you never know. So it's really very simple. Click execute. Select an organization. I'm selecting a default org. I pre-populated these variables, but these were the workflow input variables that I discussed earlier. But I pre-populated them with some information, and I put my password in, and I hit execute. And then if I flip back to my vSphere and my ACI environment, you should see inside of here a new tenant created. There's this tech field day. And VMware, you should start seeing port groups created for this infrastructure. So there's my port groups, there's my tech field day port group, which is really, really nice and really, really simple. Again, I think, Gina, to your point, folks that don't necessarily have an understanding of how infrastructure is built or how to code, this is just an ability to give them a very simple low-code environment, drag and drop, connect stuff together, and share it out so you can get infrastructure. The other powerful component of this is that I have the ability to roll this back. So I get log information, output information, everything that took place in my environment, I have this ability to see, but I also can roll it back. Now, some of the tasks that I just executed were tasks that I built, so custom tasks. I did not create any rollback features within them. I could have, but I didn't. But the tasks out of the box, the things like creating a new VMware port group, do have rollback capabilities. So just to show, inside of my VMware environment, I have a port group named Tech Field Day. It's very simple for me as an administrator to say, well, something failed. I created 19 items and the 20th one failed. How do I restart all of this? I just simply say, roll it back. And when I roll it back, I get back into my VMware environment, and now we're just rolling back those changes that we're able to roll back. In this case, the Tech Field Day port group disappears because Intersight takes care of that. Okay. Any questions about that?
Yes, I have a ton.
Okay.
I just tweeted one. One of the questions I have is, you're creating these automation tasks for VMware. That's the example you're sharing. And I know, in the past, maybe y'all play frenemies kind of, right? So how well does this actually work, creating automation for them? And then the other one that's kind of maybe easier to answer is, can you repave? So can I go in and just whack everything out and start over again?
So like do a blanket reset. I'll answer that one first. I mean, I think from what's been created, yes, you can take a workflow. This is the history of the workflows that I've just done, right? But I've done like create ACI infrastructure and then roll the ACI infrastructure back. That history that's there, I can go into any of these and say, if it has the ability to roll back, I can roll it back. So I would be able to delete this either via the GUI or API or however, and sort of get a blank slate. The question about how sorry, go ahead.
Rollback or actually, so you can't delete a config? And once you deployed it?
So it's not like Terraform destroy. It's not like that, right? Yeah. So it's not as cut and dry, I think, as that. You would roll it back, which essentially would be deleted. Would be the same concept as saying Terraform destroy.
Okay.
Okay. And then as for the VMware, we're using their open APIs. And they're published. It's the same APIs that other orchestrators, Terraform, that other orchestration platforms are using. So it's just their open published APIs. We have a partnership with them. We have CVDs built around them. And I continue to see that be the area that we're going to focus on. Okay.
Okay. Thank you.
Sure. So I have about a minute left, and I just want to make sure I answer all of your questions. And I really kind of, from the demo perspective, am done. Is there any additional questions that you have that I can answer now, or perhaps later in the roundtable or whatever?
Those tasks you are delivering with the software, can the customer modify those?
So they can
copy not only the parameters, but also the code behind it.
You're talking about the tasks here, these tasks?
Mm-hmm.
There is not the ability to directly modify them. We're working on the ability like clone, so you could clone and create your own, basically, then modify the clone.
Okay.
Yeah, but not directly modify. These are, I think, probably some of what Gina was asking, in that we kind of test these, right? We test them against the infrastructure and how they would. So versioning wise, we wouldn't want people just to change them. So.